Hello, I am John Derby. I'm a physics major at Cal Poly Pomona, and my mentor was Dr. Jean Shar. My research was modeling carbon dust around evolved carbon stars. These stars are old red giants that are losing mass in the form of gas and dust and produce most of the dust in the interstellar medium. This dust comes in aromatic and aliphatic dust types. The aromatic is the cyclic hexagons. The aliphatic is the more chain-like molecule below it. This is the first systematic study with a range of known hydrogen atom fractions from aromatic rich, that's fewer hydrogens to total atoms, to aliphatic rich, that more hydrogens to atoms in the molecule. I picked one well-studied extreme mass-losing carbon star, IRS 07134 plus 1005. It is a 21 micrometer object that is low metallicity and carbon rich. My first couple weeks were spent finding initial conditions. These include photometry from 0.4 to 100 micrometers from the 2 micron all-sky survey, IRAS, the SIMBAD database, and Mixner from 1997. The spectra are from Quark's ground-based observation in 1990 and the Infrared Space Observatory as published by Cox in 2009. Some of the parameters that were more constrained for my model were the dust geometry from observations, the stellar temperature from the spectral classification, and the angular size, also from observations. Parameters I varied more were aromatic to aliphatic grain type, opacity, and the dust grain size. The result of all this modeling was a lot of spectral energy distributions which covered a wide range of fluxes and wavelengths. This is my best match SED. I call it that because it matches the stellar emission and dust emission continuums relatively well. It does not include any emission features as we would expect at 3, 7, 11, and 21 micrometers. The carrier for the 21 micrometer feature is as yet unidentified, but we would expect the 3, 7, and 11 features to come from aliphatic compounds. The problem with these is that it's hard to get their feature to continuum ratio and the overall emission feature to match at the same time. I therefore conclude that a better model would be an average of more aromatic compounds like the one seen here and more aliphatic compounds that would contain the emission features. One thing that can change be fixed in the near future is making the dust emission continuum plot below the 21 micrometer feature. And that's it. So